Yeah, good afternoon, everyone. Today, we already started into the previous session, the Laplace and the inverse Laplace transform. We discussed some history regarding the mathematician Laplace. 1 minute. Okay. This is the application of the Laplace transform that will convert the differential equation right into the algebraic form. These are the applications, and we discuss the periodic function as well as the piecewise continuous function. This is the formula of the Laplace transform, time domain and the frequency domain. Laplace of ft equal to integration 0 to infinite e raised to minus st ft dt equal to f of s. This is the sufficient conditions for existence of the Laplace transform. F of t is piecewise continuous. This is the definition of the piecewise continuous. Function is continuous in every subinterval and has the finite limits at the end of each subinterval. This is the first formula. Prove that Laplace of the constant function equal to k by s, right? Any constant. Laplace of any constant is equal to constant divided by s. And we already discussed these two examples. Laplace of 1 is a 1 by s and 100 is a 100 by s. Then second formula, Laplace of e raised to at is equal to 1 upon s minus a, where a is a greater than 0. And using this, we discuss these two problems also. Laplace of e raised to minus at is equal to 1 upon s plus a, and Laplace of c raised to at is equal to e raised to at ln c. Now this is the linearity property, right? When the constant is multiplied with the f of t and g of t, then we can write outside before the Laplace transform and Laplace apply onto the functions. Then two trigonometry formulas. Laplace of sine kt is equal to 1 by s square plus k square. And Laplace of cos kt is equal to s upon s square plus k square. Okay. And these are the examples, and this 6 to 7 examples, right, for the practice. Everyone done these questions? Everyone done this question? Okay, tell me what is the first answer. Deepak Kumar. What is the first answer? Laplace of 1000. Yes, Deepak. Yes, Deepak, what is the first question answer? Laplace of 1000. Deepak, your voice is not coming. $1,000 is a constant, Deepak. Yes, Amit. Yes, Amit. Very good. Yes, Amit. This is 1000 by S. Okay, Deepak. Now mute yourself. No problem. Now I'm writing over here the answers. Second, Laplace of e raised to minus 80 is a 1 upon. Yes, Kinjal, what is the answer of the second one?
1 upon s plus 8.
Yes, 1 upon s plus 8. Okay, Priyanka. Now the third answer, Laplace of e raised to 5t. Priyanka. Okay, any other one? Yes, Mihir Karnavi. Okay, Deepak. Okay, Deepak, very good. Deepak is right. This answer into the chat box, and this is 1 upon s minus 5. Okay, now the fourth one answer. Yes, Kunal. Kunal, please give the fourth answer. Kunal, Laplace of sine 60. The examples are written here. Laplace.
6. 6 by a square plus 6, 36.
Very good, very good. Very good. Now the fifth one, Rishi. Rishi. Yes, Mihir, very good. Rishi. Okay.
Yes, ma'am.
What is the answer of the fifth question?
नहीं आता मैम.
Q. This is already written over here. Laplace of cos 3t, then s upon s square plus 3 square. Here write the formula also. Okay, now apply using this, both this formula as well as example. Now tell me, what is the Laplace of cos 2t? Here 3t, here 2t. Okay, apply onto the similar
S
way.
upon S square plus 4.
S upon s square plus 4. Okay, very good, very good. Okay. Okay, now the sixth answer. It's very simple. Yes, Priyanka. Now the sixth answer is 3 as it is, divide by s minus 2 plus 5 s plus 7. Right, this is the 5. And the seventh answer, anyone ready for the seventh one? Yeah, Karnavi. Yes, Karnavi, what is the seventh one answer? Karnavi?
Yes, ma'am.
Yes, what is the seventh one answer?
1 upon s minus
2
ln of 2.
No, 1 upon s minus a
Sorry.
value 8. 8 ln.
Yes, 8.
Okay, now everyone quickly check it your answers, right? If you have any doubt, any mistake, then quickly correct it. Now we will discuss the remaining two hyperbolic formulas. Not everyone? Anyone remaining to write? And those who are not present in this meeting, quickly inform this. Now we will start. Nitish. Nitish, beta, write your number. Nitish. Write your number. Write your number and name. Okay. Now, The next formula, the fifth one. Prove that yes, Nitish, in your name when you join this meeting, only rename yourself, write your number, then your name. Okay. Laplace of cos HKT equal to S upon S square minus K square. H is a hyperbolic function, right? Okay, now we solve this. Now we know that the one relationship formula for hyperbolic function and the exponential function. Cos h theta, we can write it e raised to theta plus e raised to minus theta divided by 2. Okay, and if this is the sine h theta, then e raised to theta minus e raised to minus theta by 2. Okay, now here theta we need kt, therefore we apply over here cos h kt equal to e raised to kt plus e raised to minus kt divided by 2. Okay. Apply Laplace transform both the sides. The Laplace transform short form we can written L dot T dot. Both sides. Therefore, Laplace of cos h kt equal to Laplace of e raised to kt plus e raised to minus kt divide by 2. Okay, quickly note it down this one. Therefore, 1/2 constant, Laplace of e raised to kt plus Laplace of e raised to minus kt. Using linearity property. And now apply formula number 2. Laplace of e raised to kt is equal to 1 upon s minus k. Laplace of e raised to minus kt. Therefore, 1 upon s plus k. Okay. Therefore, Laplace of cos h kt equal to half 1 upon s minus k plus 1 upon s plus k. Now apply the LCM inside this bracket, cross multiplication. S plus k plus s minus k. This is s square minus b square. This is cancel out. 2s and 2 is cancel out. Therefore, remaining is s upon. This is Laplace of cos hk. Similarly, we can prove for the sine function. Again, prove that Laplace of cos hkt equal to s upon s square minus k square. We know that cos at theta equal to e raised to theta plus e raised to minus theta by 2. Right? This is the relationship formula between the hyperbolic function and the exponential function. Here we put it theta equal to kt and apply both the sides Laplace transform. Now, as per the linearity property, we take it common 1 by 2, right? Then subtract the terms and then utilize the formula number 2. Laplace of e raised to kt is equal to 1 upon s minus k and e raised to minus kt equal to 1 upon s plus k. Okay. Now the sixth one, prove that Laplace of sine kt equal to k upon s square minus k square. Using this relationship, sine kt equal to e raised to kt minus e raised to minus kt. Okay. Now apply Laplace transform both sides. Therefore, okay. Same as the previous proof. 1 by 2 Laplace of e raised to kt minus Laplace of e raised to minus kt. Using linearity property. Now apply the formula number 2. Now therefore Laplace of sine kt equal to 1 by 2 1 upon s minus q minus Laplace of e raised to minus kt. You take it the LCM s plus q minus s minus q. Therefore, 1 by 2 s plus q minus s plus q divided by this is cancel out. Therefore, 2k, therefore 2 to cancel out, that's what remaining. Here 1 by 2, 2k s square minus k square. 2 to get it out, therefore k upon s square minus k square. This is Laplace of sine kt. Next, hkt. Right, this is the next form. This is sine hkt. Everyone schematic it down. Here. Sine h kt. Now, examples. Laplace of sine h 3t. When the sine function, then write the constant first. 3 upon s square minus 3 square. Therefore, 3 upon s square minus 9. Yes. Yes, Rishi. Okay. Laplace of cos at 3t. Here we take it some another angle. Therefore, cos h of 5. Okay. Therefore, cos function then s square minus 5 square. Therefore, s upon s square minus 25. Okay. In the trigo function formula, here the constant and the into the denominator, that is the plus sign, here the minus sign. Okay. And also Laplace of sine 3t. Okay, I'm writing with another color. 1 minute. Yes. And Laplace of cos 70. Yes, what is the answer? Yes, Vikash. Yes, Vikash. Yes, sine 3t trigo function. 3 upon s square plus 9 and cos 70, that will be s upon s square plus 49. Now this 4 formula sentence S is okay, C is sine with constant, cos with the S. If sine function, then always into the numerator the constant will, right? S for constant, S for constant. And cos function either trigo or the hyperbolic, right? Therefore, here S, and for the trigo, this is S. For the trigo function into the denominator, S square plus K square. And for the hyperbolic function, S square minus K square. Clear, everyone? Now, the seventh one. This is the gamma function. Over here, that's the power. That's Laplace of t power n. Now, n is any number like 3, 4, 5, 6, right? And integer, then you utilize this formula n factorial upon s raised to n plus 1. And when the number is the fraction, 1 by 2, 3 by 2, 4 by 3, 5 by 6, like that. Then utilize this formula gamma n plus 1 upon s raised to n plus 1. Okay. Now, before this proof, we know the gamma function. And integration 0 to s to minus x, x raised to n minus 1. Here the integration limit is the 0 to infinity. The Laplace transform, we know that definition formula limit is integration 0 to infinity. That is both the integration, is both the function Laplace and gamma function are the correct. One more formula, gamma n plus 1, we can write gamma 4 fractions. Gamma n plus 1 2 factorial 4 integers. As well as more formula, 2 is under root of n. This is the gamma function side. This angle like that. This is the gamma function. Gamma n plus 1 upon s raised to n plus 1. It's a fraction. And n factorial upon s raised to n plus 1. N is an integer. All the gamma function, gamma n equal to integration 0 to infinite raised to minus x raised to n minus 1 dx plus 1 when n is a fraction 1 by 2 plus 1 like that. We can write it like that n gamma n. Gamma n plus 1 equal to, we can write it n factorial for integers and gamma 1 by 2 equal to root. For example, mute your mic.
वो दिल्ली सब है मेरा टीम
Gamma 3 by 2. So we can write gamma 1 by 2 plus 1. Okay. Therefore, 1 by 2 and gamma n. Therefore, half gamma half. Therefore, 1 by 2 under root for the fraction, right? Now for the integers, gamma 4. Therefore, gamma 3 plus 1. And this is equal to 3 factor. This is the 6. Here, these are the examples of the gamma functions. More example, if gamma 5 by 2, 3 by 2 plus 1, therefore 3 by 2, 3 by 2 as it is, and we can write half plus 1, therefore 3 by 2, 1 by 2, therefore 3 by 4. Okay. Clear everyone the gamma function? Quickly write yes into the chat box. Now, formula Laplace of now for our formula. By definition formula, Laplace of t power n. Integration 0 to infinity s2 minus st t power n dt. This formula here. Now we take with some assumptions. Let s into t equal to u. So t equal to u by s. Okay. Differentiate this. dt equal to du by s. Then equal to 0. We apply into solve the equation number 1. Quickly note it down. Therefore, equation number is plus of t comma n is equal to integration 0 to infinity e raised to minus 2 raised to t is u minus is as well as dt is this is u raised to n s raised to n. We can apply that. This is s. This is having 0 to right outside s raised to n plus 4. S raised to n plus 1 0 to raised to minus 1. Here we have to apply the gamma formula, and this is form is not into the gamma function. Therefore, into the power we change, adding plus 1 and subtract. Okay. And now this is the gamma and plus 1 formula. Right. See the previous slide. That's one of the instant method of the gamma. This is the gamma n minus 1. Gamma n plus 1, then here n plus 1 minus 1. This is our result. We have to do this result. We are utilizing the gamma function here, therefore we revise the gamma function. Now we apply the definition formula. We utilize some assumptions as into t equal to u. Therefore, p value is u by s and dt is equal to du by s. T equal to 0, then u is also 0. When t tends to infinite, u tends to infinite. Apply here the assumptions. Now u power n, this is the division, and apply the separate one. S raised to n and f, that s raised to n plus 1, e raised to minus 2, u power n. Therefore, e raised to minus 2, u raised to, we arrange this term here, adding plus 1 and subtract. Because this is the formula of the gamma function. Gamma n plus 1 whole s raised to n plus 1. Gamma n plus 1 is equal to n factorial for the fraction. Sorry, here the fraction. N is fraction. And Now we may keep the list of the Laplace transform formula. Keep the table. Laplace of the first formula, this is constant, this is k by s. S minus s minus 18 s plus g upon s square plus k square cos k s upon s square plus the formula k is the constant. Okay. Hyperbolic formula cos hkt s upon s square minus k square sin hkt s square minus k square. Last one. Plus one plus n plus one fraction factorial upon s plus one plus one 4 Laplace of any constant and constant by s. Please remember like that. Laplace of e raised to 18 is any constant and 1 upon s minus n. If you write it over k, then 1 upon s minus k. And Laplace of e raised to minus 8. Right? T coefficient is subtract from the s. Therefore, 1 upon s plus n. Laplace of sine kt. This is k upon s square plus k square. Laplace of cos kt. This is s upon s square plus k square. The hyperbolic functions. Laplace of cos hkt. This is s upon s square minus k square. And Laplace of sine hkt. This is k upon s square minus k square. And then the t power n. N is a fraction, right? 3 by 2, 5 by 2, 8 by 9, like that. And use this formula, gamma n plus 1, s plus 2, n plus 1. When n is an integer, 2, 3, 4, 5, 9, 100, right, like that. And n factorial upon s raised to n plus 1. Okay. Now, this is the last formula, 8th one. We will discuss some problems based on that first. For example, the plans of t equal to 100. So, 100 factorial, this is the integer. S raised to 100 is 1. 100 factorial s raised to 1. Plans of 4 factorial s raised to 4 plus 1. This is one n factorial, s raised to n plus 2. 4 factorial means 2 into 5 s raised to 4. S raised to 4. Laplace of t raised to half for gamma half plus 1 s raised to half plus 1. Now, that this gamma n plus 1 we can write n gamma n using the gamma function properties. S raised to 3 by 2. Gamma half value is 2 by s raised to 3. Example, t raised to 3 by 2. Yourself, everyone. Write your answer into the chat box. This is gamma t by 2 plus 1 is raised to 3 by 2 plus 1. And 3 by 2. Convert plus 1 by 2 is raised to 5. Okay. This one. So half, comma half, half into even please note it down distance. This is very useful for the problems. This is 3 minus 1. 3 by 2 answer is and voice is clear. Now this is clear. Yes, now voice is clear, Kunal. Okay. Now, next one, gamma 7 by 2. Therefore, we can write Kunal here. You can unmute yourself in the formation of the plus 1. 7 by 2. Write it into the formation of the plus 1. Kunal, unmute yourself. Yes.
Yes, ma'am.
Yes. This gamma 7 by 2, 7 by 2, write into the formation of the plus 1 like that. 5 by 2, therefore 3 by 2 plus 1. Then 7 by 2 is? Yes. Yes. Yes.
5 by 2 plus 1.
Okay, very good. And Priyanka also wrote the answer into the chat box. Okay, now you can mute yourself. Therefore, 5 by 2, gamma 5 by 2. And gamma 5 by 2 answer is available here. 5 by 2. And write this 3 by 2, 1 by 2, root by using 2. Okay, now everyone clear? If gamma 7 by 2, then we can start from 5 by 2, 3 by 2, 1 by 2, root by. Yes, Nitesh. But divide by 5 by 2. Now, same way, gamma 9 by 2. Therefore, 7 by 2 plus 1. 7 by 2, gamma 7 by 2. No, Priyanka, no. Generally, in the Laplace transform, this is the term is always mostly the division by 2. Okay. Yes, Mitesh, very good. Yes, Amit. Seven by 2, 5 by 2, 3 by 2, 1 by 2, root by. Okay. And the last one, and you can Find like that 11 by 2. Now everyone write your answer into the chat box. 9 by 2 plus 1. Yes, Amit. 9 by 2. Therefore, 9 by 2. Yes, Rosh. Okay. Clear, everyone? The gamma function. One minute. These are the example of the t power integer as well as the fraction. Now, please remember this table, everyone, right? Or tomorrow, I repeat it again, this table. Laplace of the any constant, this is constant divided by s. Laplace of e power at, then 1 upon s minus a. Laplace of e power minus at, then 1 upon s plus a. Laplace of the sine kt, then k upon s square plus k square. Laplace of the cos kt. Here always the fraction is given by division by 2, right? Never like that 3 by 4, 15 by 8, 17 by 9, like that. Okay, always division by 2. Okay. Laplace of cos kt, this is s upon s square plus k square. Then the two hyperbolic formula, Laplace of cos h kt, s upon s square minus k square. And Laplace of sine h kt, then k upon s square minus k square. And then the last formula is the t power n. That is depends on the nature of the n. Either n is an integer or n is a fraction. If n is an integer, then gamma n is integer, then apply n factorial s raised to n plus 1. And if n is a fraction, then gamma n plus 1 upon s raised to n plus 1. Okay. Now revise this formula. One minute. Wait for the 1 minute. CV 1247 10 11, 12, 13, and 14. One, two, three, 7. Ten, 14, 16, 18, 19, 20. Thank you very much, everyone. Have a good day.